Now we study the next function, which is greatest integer function, and it is denoted as x written in square brackets, right? This function is defined as the greatest integer less than or equal to the x. So that means whatever is the greatest integer which is either less than or equal to the given number x is called as the greatest integer function and denoted by bracket x. Now let's try to draw the graph of this particular function so that we'll have some idea how it looks like. So here I plot some of the sample points on x and y axis. Alright, now let's consider the simplest number, that is 0. Now for 0 we know that the greatest integer less than or equal to 0 is 0 itself, right? See, if I say in general the integer less than the given number, then there will be countless integers, but out of all those integers we want the greatest. So for 0 it is 0. Now if you consider all the numbers between 0 to 1 except 1, alright, so starting with 0 up to 0.9999 and so on. For all the numbers, the greatest integer which is equal to or less than them is nothing but 0 only, isn't it? So therefore for all these numbers the graph will have the value as 0 only, isn't it? But the moment we touch 1, what happens is the greatest integer which is less than or equal to 1 is nothing but 1 itself, isn't it? So therefore at 1 the graph will take a jump and it will shift to value 1. Now once again, if you continue from 1 and all the further numbers just before 2, that is 1.1, 1.2, 1.9999 and so on. For all these numbers the greatest integer which is less than or equal to themselves is 1. So therefore it will have the value as 1. And at 2 it will take a jump and it will go to the 2 and so on. It will again continue up to 3 and take the jump. So similarly on the negative side also we have the similar structure, and we see that it looks like a staircase like patterns, that is there are breaks at the integer points. So this is a very important observation, that this is a kind of step function. It looks like a staircase and there are breaks at the integer values of x, right? That is the greatest integer function. Now let us see the domain and range of this function. Now domain once again is the set of all real numbers, because every real number can be given as an input to this function. And if we consider the range, it's clear from the graph that on the y-axis we are going to have only the integer numbers as the values of this particular function. So therefore the range is nothing but the set of all integers. That is the greatest integer function. Now let us see some of the important results or properties related with this function. The first property says that x minus 1 is less than bracket x, which is less than or equal to x. So in other words, the greatest integer less than or equal to x lies between x minus 1 and x, and there is a possibility that there is equality on the right hand side, because if x itself is an integer, then the value of bracket x will be nothing but x itself. So in that particular case we have the equality on the right hand side, but otherwise it will be less than only if x is not an integer. The second property says that if bracket minus x plus bracket x is done, then it is equal to 0 if x is an integer, but if x is not an integer, then the answer will be minus 1. And this also we can quickly verify using any example. Third property is a bit peculiar, we have to remember it properly. That is greatest integer of x by n plus greatest integer of x plus 1 by n and so on up to greatest integer of x plus n minus 1 whole upon n is equal to greatest integer of x itself, and here n is a natural number. So these are some of the key properties of greatest integer function. Now let's go to the next function, which is called as the fractional part function, right? And that is denoted by x written in braces, that is the curly brackets. So fractional part of x is defined as x minus greatest integer function of x, so that is x minus bracket x. Now let us see how does graph of this particular function looks like. So here you have 1, 2, 3, here we have minus 1, minus 2, and so on. Here you have y, here it is x. Now by fractional part we mean that x minus bracket x. So if we start with 0, we can see that x is 0 and bracket x is also 0. Let us start off with a very small positive number, say 0.1. Okay. So x is 0.1 minus what is the integer of 0.1, that is greatest integer of 0.1 is nothing but 0, so that gives you 0.1 itself, isn't it? Now let's consider a slightly bigger number, say 0.5. Now for this number also the greatest integer function is 0, so that gives us 0.5. Now let's go little near 1, so we have 0.9. Here also the greatest integer function is 0, so we get 0.9. So you see that whatever is the value of x, same is the value of fractional part if x lies between 0 to 1. Now the moment it touches 1, what happens is 1 minus, now the greatest integer function for 1 will be equal to 1 itself, and that will pull down to the answer to 0. And this point onwards, let's consider another next number, say 1.1. For 1.1 the greatest integer is once again 1, so that will pull it down to 0.1. Then if you consider 1.5, if you see we are following the same pattern here. So for 1.5 we have 1.5 minus 1, it is equal to 0.5. So you see basically the same pattern of fractional part will repeat. So therefore we see that starting with 0 it goes up to 1, at 1 it falls down to 0 once again it starts rising, goes to 2 and falls down at 2, and so on. Alright, and here also for starting with minus 1 it will go up to 1, then from minus 2 to minus 1 it has exactly the same pattern, right? So remember that especially on the negative side it is very important to note that fractional part does not just mean this, that whatever is the fractional decimals that is the answer, because it could be misleading there. Let's take an example here. See, for positive it is fine, we can say that, say fractional part of 1.3 is equal to 0.3. So in a way we are just skipping the integer part and writing 0.3. But remember that fractional part of minus 1.3 is not at all equal to 0.3 just because it looks like the fractional part in the number. So what is it? Let us see what that is. If we see minus 1.3, okay, minus 1.3 will be somewhere here, right? So what happens is actually the fractional part is nothing but here, so it will be nothing but 1 minus the fractional part which is visible in the number, so that will turn out to be 0.7, and that is anyways evident even if you find out the answer using the definition, but this is a simpler approach to find out the fractional part. So here the fractional part of minus 1.3 will be equal to 0.7, right? So that is what we have to keep in mind for especially the negative numbers. Now if we talk about the domain and range, here we can see that once again the domain is same as the set of all real numbers, And if we see the range now look here properly. What does range mean? Range means on y-axis which values it occupies. So we see that starting with 0 onwards, it goes up to all the values just before 1. Alright, so between 0 and 1, all the values except 1 are possible. So that means we have this kind of semi-closed interval or semi-open interval, that is 0 is included but 1 is not included, and of course all the numbers between 0 and 1 are included. So that is the range of this fractional part function. Now let's see some of the properties of this function also. The fractional part of x plus fractional part of minus x is equal to 0 if x is an integer, but the same is equal to 1 if x is not an integer. Alright, so this is the important point that we have to remember. The third property connects the greatest integer function as well as the fractional part function. So you see that the left hand side, or rather the statement of the property, is involving the greatest integer function, whereas the conditions are involving the fractional part function. So the greatest integer for x plus y is equal to greatest integer of x plus greatest integer of y, provided fractional part of x plus fractional part of y lies between 0 and 1, and there might be equality on left hand side, that is 0, but that is equal to greatest integer of x plus greatest integer of y plus 1 if the fractional part of x plus fractional part of y lies between 1 and 2, and once again the equality on the left hand side 1. So these properties can also be easily verified using any example.